Okay, let us continue. So in this lecture, let us find out the 3 dB frequency of Chebyshev filter. Okay, if someone asks you to find out the 3 dB frequency of a Chebyshev filter, then how will you find out? As I said, the 3 dB frequency is a very important factor in Butterworth filter. Okay, this is important in Butterworth filter, but it is not important in Chebyshev. Okay, in Chebyshev, what are important are omega p and epsilon. Okay, if someone asks you to find out a 3 dB frequency, then obviously the equation defining the 3 dB frequency would be let's say the magnitude function is 1 divided by 1 plus epsilon squared Cn squared of omega. Let me write on the general expression and then we will derive omega by omega p and whole square root, and this is magnitude He of j omega. Now 3 dB frequency is a frequency at which the magnitude is going to be 1 by root 2 or 0.707 of the maximum value. You square it on both sides, then it is 1 divided by 1 plus epsilon square Cn squared of omega, and this condition happens when omega is equal to omega p. Therefore in the numerator I put omega p, in the denominator also no, not cutoff frequency, I am very sorry. This is the cutoff frequency, so omega c divided by omega p. If you square it on both sides, then it would be 1 by 2, and therefore Cn squared of omega c divided by omega p is equal to, of course don't forget this epsilon squared, equal to 1. Okay, so Cn squared of omega c by omega p is 1 over epsilon squared, and this can be plus or minus. If you take square root, then Cn of omega c by omega p is plus minus 1 over epsilon. Now I can take plus and minus and find plus omega 3 and minus omega 3, but let us take plus sign. Okay, so Cn of 3 dB frequency is 1 over epsilon. Now obviously this 1 by epsilon will be greater than 1. Why? Because epsilon is a small value, right? So therefore 1 by epsilon will be greater than 1. Isn't that right? So epsilon normally is a very small quantity. Therefore 1 over epsilon must be greater than 1, and therefore for Cn I should use which function, cosine function or cos function? This is greater than 1, therefore Cn of omega 3 by omega p I must use cos function. Okay, so cos of n cos inverse of x. Instead of x I have this parameter excuse me, oh my god, let me write down properly. Okay, so Cn of omega 3 by omega p. I should use cos function, cos n cos inverse omega 3 by omega p. Okay, and this must be equal to 1 over epsilon. So n cos inverse of omega 3 by omega p is equal to cos inverse of 1 by epsilon, right? Cos inverse of omega 3 by omega p is 1 over n cos inverse 1 over epsilon. So from this, if we simplify, omega 3 is equal to omega p times cos of 1 over n cos inverse 1 by epsilon. So this is how you will find out the 3 dB cutoff frequency of the Chebyshev filter. Okay, so this is the expression for the 3 dB frequency. Now, just out of curiosity, what is a 3 dB frequency? This 3 dB frequency omega 3 obviously will be greater than omega p if epsilon is less than 1. Okay, so that's how you will find out the 3 dB frequency in the Chebyshev filter. Now, next, the question of poles and pole factors. Poles and pole factors. Obviously, the pole factors will satisfy 1 plus epsilon squared Cn squared of omega p omega by omega p. Okay, because there is a denominator polynomial, the denominator must be equal to 0. Okay, in the Chebyshev magnitude function, this is the denominator, and this denominator should be equal to 0 in order to find out the poles. Okay, and don't forget this epsilon squared. Now you substitute s equal to j omega. Therefore omega is equal to s by j. Okay, so this expression becomes 1 plus epsilon squared Cn squared s by j omega p is equal to 0. And this expression turns out to be a lot of complex algebra to solve it. Okay, and which we will not go into due to time conditions, due to insufficient amount of time. Okay, but the end result is, but I will give you the end result. Okay, so the end result is that the poles are located on an ellipse. If you find the poles, these poles are located on an ellipse instead of a circle in the Butterworth case. So for Chebyshev filter, the poles are located on an ellipse, but if you take Butterworth filter, the poles are located on the circle. Okay, so poles are located on an ellipse, and the pole locations are such that finally the transfer function HA of S, okay, so I will simply give you the result, has the factors S plus omega p times C0, and this is a first order factor, and then S squared plus bk omega ps plus ck omega p square. I just gave you the result. Okay, this result you got it after solving this equation. Let me call this equation number 1. And solving of this equation involves a lot of complex algebra, so that is why I did not go through the process, but I am just giving the end result. Okay, so the first order factor would be like this, and the second order factor would be s squared plus bk omega ps plus ck omega p squared. Okay, in the Butterworth case we had simply s plus omega c, but here we have one additional factor c naught. Okay, so in this case it is omega p multiplied by another constant c naught, and such a factor will arise in the denominator only when the order is odd. This factor arises only in the denominator when the order is odd, and if the order is even, then you will be having this quadratic factor a squared plus bk omega ps plus ck omega p squared. Okay, so the first factor is this one, s plus omega p c naught, and the second factor would be a quadratic factor. And these bk's are different, and we will illustrate them a little later. Okay, therefore s plus omega naught s plus omega p c naught s squared plus bk omega pc omega ps plus ck omega p naught square, these are the pole factors. These are the factors in the denominator. In other words, when capital N is odd, then the transfer function HA of s is equal to s plus omega p c naught multiplied by continued product of s squared plus bk omega p s plus ck omega p squared. Okay, and the numerator will be omega p to the power capital N. Okay, and before that let me finish the limit of this continuous product. The limit is k equal to 1 to n minus 1 divided by 2, because the order is odd, one factor is appeared here, so then I have this many number of n minus 1 by 2 number of second order factors. Okay, so in the numerator I have omega p to the power n, and then c naught I have it, and then continued product of ck. Okay, k equal to 1 to n minus 1 divided by 2. Why do I need these factors in the numerator? What is the reason? Okay, see, if you look at this omega p to the n, that comes from the denominator. Okay, so when s equal to 0, that is at DC, I wanted to make sure that the magnitude is 1. Therefore we have brought all the denominator constants in the numerator. So the DC value of this transfer function would be equal to 1. Okay, in this expression, suppose if we substitute omega equal to 0, that means s equal to 0. If we substitute s equal to 0, then this guy will go away, this guy will go away, this will go away. So you left with the denominator omega p c naught, then continued product of how many times? n minus 1 by 2 times. Okay, and here this is 0, this is 0, and you left with ck and omega p squared. Okay, therefore what about the numerator? The same factor, you bring this numerator here. So omega p to the n c naught, then pi of k equal to 1 to n minus 1 by 2. And here I am sorry, I did a mistake here, I am very sorry, I beg your pardon. So pi of k equal to 1 to n minus 1 by 2 within a bracket 0 plus 0 plus ck omega p square. Right, now simplify this. In the numerator, omega, this c0 will get cancelled, omega p to the n, then pi k equal to 1 to n minus 1 by 2 ck, in the denominator omega p. Then in this continued product, the denominator in this continued product, this omega p squared is a constant. So I can take it outside, omega p squared and power n minus 1 by 2, and continued product of k equal to 1 to n minus 1 by 2 ck, and this 2 and that 2 will get cancelled, this one. So the denominator omega p times omega p to the n minus 1, so this is omega p to the n, and this and that will cancel numerator. Okay, so omega p to the n, continued product of ck, k equal to 1 to n minus 1 by 2, denominator omega p to the n, continued product of ck. So this will give you 1. So that is why we brought this all denominator constants to the numerator, in order to make the DC value of this transfer function would be equal to 1 when s equal to 0. Okay, so this is the transfer function for odd order. Now in case if you have an even order, then one minute before going to the even, this is HA of S, so HA of 0 is equal to 1. Okay, therefore for an odd order Chebyshev filter, what is the DC value? 1. In case if you recall, for an even ordered Chebyshev filter, what is the DC value? This is for odd order. If it is even value, if you recall, that is going to be 1 divided by square root of 1 plus epsilon squared. Okay, you must remember this. Okay, so we have constructed the transfer function for odd ordered filter. Now the constants C0, Ck and Bk's are, I am going to give you in a minute. Okay, so there are formulas that I will give you, but before that let us finish this even, when n is even. Okay, if the order is even, now this is a difference. Okay, then HA of S is equal to the continued product of S squared plus Bk omega Ps plus Ck omega P squared, K equal to 1 to n by 2, and in the numerator we will get omega P to the n. Okay, omega P to the power n, capital N, and continued product Ck, K equal to 1 to n by 2. Okay, so now this means the DC value is going to be 1. Okay, so in this expression if you substitute s equal to 0, then you'll get 1. But for capital N is even, see our condition is capital N is even. If capital N is even, the DC value is not 1, it is going to be 1 by square root of 1 plus epsilon squared. Okay, therefore I must multiply the numerator by 1 by square root of 1 plus epsilon squared. Okay, so this is an important point. So whenever your order is even, then this is the transfer function. So you must not forget this factor 1 by square root of 1 plus epsilon square. If the order is odd, the magnitude starts from 1, right? If the order is even, the magnitude starts from not 1 but 1 by square root of 1 plus epsilon squared. Okay, so all these constants, this constant were required to make the magnitude equal to 1. Okay, these constants are required to make the magnitude equal to 1 when s equal to 0. But this factor but this factor 1 by square root of 1 plus epsilon square has to be added. Why? For n is even, then the magnitude starts from 1 by square root of 1 plus epsilon squared. Okay, so you have to proceed with the caution. Now it's time to tell you what this B case and C case are. Okay, these formulas you must keep it in your prominent place. Okay, and C naught. First let me not in this order. Okay, so first we need to find out C naught. Okay, C naught we defined as y suffix capital N, and C naught we have not yet found out. Okay, but we defined it to be equal to yn to indicate that it is a characteristic of the order of the filter. Okay, this n indicates this yn is going to be the characteristic of the order of the filter. Therefore the C naught depends on the order of the filter. Okay, therefore C naught is yn, which is okay, and this yn depends only the order, and this is going to be 1 by 2. It's a lengthy formula. Square root of 1 plus 1 by epsilon squared plus 1 by epsilon whole to the n, 1 by n, minus same square root of 1 plus 1 by epsilon squared plus 1 over epsilon to the power minus 1 by n, and you put a curly bracket. So this is the formula to find out the yn. From y suffix capital N you can find out C naught. Okay, yn only depends on the order. Now the next coefficient Ck is given by yn squared plus cosine squared 2k minus 1 pi by 2n. If you remember this angle 2k minus 1 times pi by 2n, it is familiar, right? It is the Butterworth angle, isn't that? If you recall Butterworth filter design, BK was defined as 2 times sine of 2k minus 1 pi by 2n. So this 2k minus 1 pi by 2n again appears here, but instead of sine I have cosine, and I have one more factor, this yn squared also. Okay, so Butterworth filters were expressed in terms of sine of 2k minus 1 pi by 2n. In Chebyshev, because we require constants, this ck and yn in the constant term of the denominator. Okay, see, I need these constants, bk's and ck's and yeah, okay, so I need to find out, I need to include these guys in the formula also. So this can be derived, but I didn't go through the derivation. Okay, they can all be derived, but there is a lot of algebra involved. so I want to go into that. And the next one is bk. In the previous case, bk is 2 times this guy, but now bk is the Chebyshev filter. In the Chebyshev case, bk is simply multiplied by yn. Okay, and don't forget this 2 times yn sine of 2k minus 1 pi by 2n. Okay, in the Butterworth case, this ck's were equal to 1, but here ck's are not equal to 1. Okay, so in Chebyshev filter, the factor yn comes. Okay, if you notice, I have yn here to calculate bk, and here also I have yn squared to calculate ck. Okay, so if you notice, in Chebyshev filter, the factor yn comes because of the shrinking of the circle into an ellipse. Okay, you have the circle and shrink in this direction, then it becomes an ellipse. Okay, it is as if you press from the two sides and it elongates and shrinks in the middle. Okay, it elongates and shrinks in the middle. Okay, therefore this yn appears in the b case as well as in the c case. Now I have given yn also, so this yn completely depends upon the order of the filter and epsilon value. Okay, and this yn requires a little bit more calculation, but it is not too difficult. Okay, so I have given the expression. So let me rewrite this yn neatly. There is a more chance to make an error while calculating this yn. 1 by 2, 1 plus 1 by epsilon squared square root plus 1 by epsilon, and this whole thing you make it like this, minus, did I put minus here? Yes, minus the same factor. Okay, 1 plus 1 over epsilon squared square root plus 1 by epsilon, then to the power minus 1 by n. Okay, and then let us make this curly bracket like this. So this is yn. So given capital N and epsilon, you can find out the transfer function. Okay, capital N and epsilon are the only two parameters of a Chebyshev filter. Once you know this capital N and epsilon, you can find out the transfer function. Okay, now let us take an example. So as an example, suppose capital N is equal to 4 and epsilon is equal to 0.8. Then the calculation proceeds like this. Okay, and now to calculate this yn, c case and b case, you can make a small program. Okay, now the first step is, as I said, you have to find out c0, ck and bk. Before that you have to find out y suffix n. So the very first step is you have to find out y suffix capital N is equal to 1 by 2, 1 plus 1 by epsilon squared, that is 0.64 square root plus 1 by 0.8 whole to the power 1 by 4. minus same expression 1 plus 1 by 0.64 square root plus 1 by 0.8 to the power minus 1 by 4. Okay, it requires a little bit of calculation. Okay, and don't make a mistake, and here also positive and here also positive, both are positive. The only difference is here 1 by 4 and here minus 1 by 4, that's it. The power is positive and here the power is negative, and here of course there is a negative sign. Okay, so both of them identical factors, this guy and this guy, both of them identical factors, only the power is positive here and here negative, that's all. That's it. Okay, so this works out to 0.26490, and if you ask me that this 0 is insignificant, right, but this is significant here. Okay, I could have omitted this 0, but it shows that I have corrected up to 5 decimal places. Okay, 5 places of decimals. Okay, and this is yn, and as I said, yn is the same as C0. But anyway, if the order is even, then C0 is not required. Okay, because only when the order is odd, then in the denominator you have the first order pole. If you look at, see, first order pole, then you need this. C0 is needed. So C0 is needed only if the order is odd, otherwise we don't want. For even ordered filter, we don't require C0, but anyway that is needed to calculate other coefficients. Now what is B1? We know the formula for B1. Okay, so B1 is equal to twice y suffix n, let me write BK general formula, 2k minus 1 by so substitute k equal to 1, B1 is equal to 2y4 sine of pi by 8, and that comes out as 0.20275 B1, and B2 is equal to 2 times y4 sine of 3 pi by 8, this is 0.48947 and then Ck, by definition Ck is yn squared plus cos squared 2k minus 1 pi by 2n. Now substitute k equal to 1, C1 equal to y4 squared plus cos squared pi by 8. That calculates as 0.92373. Okay, it is no longer possible to keep them as fractions, unfortunately. C3 is equal to y4 squared plus cos squared, just add 2 pi in the numerator. Okay, so therefore 3 pi by 8, so that comes as 0.21662. Please do verify these values. Okay, so the problem now is to find out these values like B1, B2, C1, C2. Is it C3? I beg your pardon, this is C2, C1, C2, and then yn is no needed to calculate these coefficients. Therefore your transfer function is HA of S is equal to, you know the general formula, so A squared plus B1. Okay, you can write the expression B1 omega PS plus CK omega P squared multiply by A squared plus B2 omega PS plus CK, I'm sorry, not this is CK, this is C1 C2 omega P squared, the numerator omega P to the power 4, then C1 C2. Okay, if you go to the function, then general formula. Okay, and this factor is here 1 by square root of 1 plus epsilon squared, so you add that also. 1 by square root of 1 plus epsilon squared. You substitute all the values. Okay, omega P we know, C1 C2 everything substitute there, and then finally you will get the transfer function. So that's how one can calculate the transfer function of a Chebyshev filter. Okay, so let me stop in this point. In the next lecture we will see how to find out the order of the filter and epsilon. Okay, so how to find capital N and epsilon from the given specifications. Generally, you know, the designer will not get the order and epsilon. It is his job to find out the order and epsilon from the given specifications. As I said, the specifications are the pass band and stop band attenuation, pass band frequency, stop band frequency, and what else? These 4 specifications we need to find out the order and epsilon. Okay, that we will discuss in the next lecture. Thank you very much.